So this problem is asking us about a typical poker hand which consists of 5 cards. And it wants to know in how many different ways can I get a hand that contains 5 face cards, 3 jacks and 2 kings, and 2 tens, 2 threes, and a jack. So obviously you have to know something about the way a deck of cards looks in order to answer this question. Let's assume that you do, and let's talk about the hand containing 5 face cards. Now here's the thing. When we want to talk about a hand with only face cards, all of the other cards in the deck really become irrelevant. When we think about cards, we think about them sort of being turned away from us. But if you imagine all the cards laid out face up in front of you, and we want to start pulling out 5 face cards at a time, all of the other cards, ace through 10, really become irrelevant, and we can push those to the side. So what happens is we're really only looking at the cards containing jack, queen, and king, which means that our N in this example is 12 and our R is 5. So we're choosing 5 out of the 12 cards that we have. So this is going to be a combination, and the truth is any problem that involves a hand of cards is going to be a combination, because if you think about it, if you take the cards that are in your hand and you reorder them, it's really the exact same hand that you had before. So the order doesn't matter, and this is a combination. And so we have the combination of 12 things taken 5 at a time. And this is going to look like 12 times 11 times 10 times 9 times 8. Remember, we start 12 factorial and we go out 5 spaces, divided by 5 factorial, which is 5 times 4 times 3 times 2 times 1. Now, with these kinds of fractions, it's always best to simplify before you multiply. So since in the bottom, in the denominator, we have 4 and 3, which is 12, we can reduce that with the 12. And we have the 5 and the 2, which is 10, and we can reduce that with the 10. And so we end up with 11 times 9 times 8, which is just 792. And so that's the answer to the first problem. Now, here it gets a little more complicated. It says, in how many different ways can I get a hand that contains 3 jacks and 2 kings? Well, in order to do this problem, we need to understand, again, you're looking at all the cards in front of you, and you're really only looking at the jacks and the kings. Everything else fades away. And so what happens essentially in this problem is that we end up with 2 different tasks. The first one says, we need to choose our jacks. That's the first task. And the second task is we need to choose our kings. Well, how many jacks do we have? We have 4 altogether. So we have the combination of 4 things taken 3 at a time because we want 3 jacks. And for the kings, we have the combination of 4 things taken 2 at a time because we are looking at 2 kings out of the 4 that we have. So this is actually the setup of the problem. And so we've got 4 times 3 times 2 over 3 times 2 times 1, and 4 times 3 over 2 times 1. The 3 and the 2 can cancel. Here the 2 can reduce with the 4, and so all we're left with is 4 times 2 times 3, which is 24. So there are 24 different hands that can be made from 3 jacks and 2 kings. Now let's look at the last example. 2 tens, 2 threes, and a jack. So like the problem before, this is a problem that is made up of different tasks. So in this example, there are actually 3 tasks. The first one is to choose the tens, the second one is to choose the threes, and the third one is to choose the jacks that you're going to put in your hand. And again, we start off with 4 of each of those. So the tens are going to look like 4 choose 2, because we're picking 2 tens out of the 4 tens that we have. The threes is also going to look like 4 choose 2, because we're choosing 2 threes. The jacks, on the other hand, since we're only picking 1 jack, that's going to look like 4 choose 1. So we have 3 tasks in this problem. So if we set this up, we've got 4 times 3 over 2 times 1. Again, we have 4 times 3 over 2 times 1, and then 4 choose 1 is just 4. Well, I can take the 2 with the 2, and I can cross that off with the 4, and all I'm left with is 12 times 12, which is 144. So there are 144 different hands that can be made from 2 tens, 2 threes, and a jack.